Okay, so you did in Algebra 1, you should have done direct variations and inverse variations. In Algebra 2, we add joint variation and combinations of all of them, which could be infinite. But it's, not just an SOL thing. These are very typical SAT kind of questions too. And they're very predictable. The way they're asked is always very, very predictable. And this is the only day we're going to spend on this. And then after that, we go into the rest of the unit is about sequence and series, which is different, but in the end, half of the formula sheet is all about sequence and series. So you get formulas for them. You just have to know how to use the formulas. That shouldn't be that hard, but sometimes I underestimate that. So these are the different kinds of variations. I don't know if you remember doing this in Algebra 1. Direct variation, y equals kx. Inverse variation is y equals k divided by x. The way I always think of it is, direct means that because x and y are at the same level, they're both in the numerator. If I increase x, I necessarily increase y. They vary in the same direction. But if in an inverse variation, because the x is in the denominator, right? If I increase the x, I'm actually decreasing the y. Or if I decrease the x, I'm increasing y. They're going to change in different directions. Joint variation. After you see direct variation, you might think, well, isn't that just a direct variation? And it is, right? It's the direct variation with a product x times y. But that has a special word, right? So we got to use it. It's a joint variation. And then you could you could have direct with something, inverse with something else, joint with something, inverse with something else. So there's all kinds of combinations you can come up with. But the one thing that they all have in common is a k, right? And in this case, the k is a constant. Now, in the book, they use a for some reason, but the SOL and everything I've ever dealt with before was always k. Somebody said, why wasn't it c? And I have no idea why do we just always use k for the constant of variation. It reminds me now, thinking of it, that was a joke that they used to tell about the University of Nebraska. They'd say, you know what the N stands for? Knowledge. They're making fun of their football team, being stupid. But in any case, our k is for constant. But in the book, they call it a constant of variation, but the SOLs are always call it a constant of proportionality. So either one means the same thing. And we are reviewing a little bit of the direct and inverse before we get into the others, in case you don't remember very much. So write a direct variation equation that has -4/8 as a solution. Okay, well, let's see. The direct variation is, as we said before, that's y equals kx. Now, if I compare that to mx plus b, what I can tell is that this is a linear relationship, right? Because both x and y are raised to the first power. What's missing in the direct variation that you see in the slope-intercept form? There's no b, which tells you what? That b equals 0. Right, so this is going to go through the origin. So if I graph this one point, I've got a direct variation, straight line equation. It goes through the point. I'm going to estimate here. -4/8. And because it's direct variation, I know for sure that it goes through the origin, 0, 0. Right? So if I sketch that line, For me to write the direct variation means I got to fill in for k. But k is what? What does k represent in terms of this line? It's the slope, right? So actually all you have to do is calculate the slope. Now, how do you usually calculate the slope? You plug in 2 points, right? Well, they gave you 1 point, and because it's direct variation, you've got another point too, right? So actually you could just use the formula. y2 minus y1 divided by x2 minus x1. But if x1, y1 is 0, 0, in the end it's just y divided by x. Right? For the slope of a direct variation, it's just the y-coordinate divided by the x-coordinate. Right? So here I can fill it in. I can go m equals 8 minus 0 divided by negative 4 minus 0. But that's just 8 divided by negative 4, which is negative 2. So here's the equation. Y equals negative 2x. Again, remember that the k is a constant, right? The x and y, those are variables. They change. This is a line. It's made up of infinitely many points, each with the x and y coordinate, right? They change. The k is a constant. We don't know it when we start the problem, but it's not changeable, right? Once we figured it out, we plug it in, and then that's our equation forever. So here's your first U-try of the semester. Try to do the same thing with that. So what is the value of k for this problem? It's the y divided by the x, negative 1/3. So, but you were asked for the direct variation equation, so it's y equals negative 1/3 x. Easy stuff, right? Too easy. Embarrassingly easy. Okay, now we got to determine whether these are direct or inverse. And in order to compare it with the formulas that we've got, right? The one was y equals kx, and the other was y equals k divided by x. We should solve for y. So how do I solve this first one for y? Divide by x. So y equals 7 divided by x. Is that direct or inverse or neither? It's the inverse, right? Inverse. Looks like that. How about the next one? Y equals x plus 3. Neither, because y gave. Well, I mean, there is a slope of this line. What is it? It's 1. I mean, you can't say that there's nothing there. There's something there. It's a 1. The problem with it is what? It has a y-intercept which is not equal to 0, so that can't be a direct variation. It's definitely not an inverse variation because that x is not in the denominator, so it's neither. So b does not equal 0. So therefore, neither. And how do you solve the last one for y? Multiply by 4, right? So you get y equals 4x. So direct or inverse? Direct, it looks like this. And what is the value of k? Direct. K equals 4. Okay, you try this one. If it's direct or inverse, then say, what is the value of k? What about the first one? Okay, I mean, this one, it's already solved for y. If it doesn't look like it, just switch sides. That's a property. That's symmetric property. So that's direct. K equals 3. How about the next one? right? That's y is 0.75 divided by x. So that's inverse. K equals 0.75. And last, yep, b does not equal 0. Neither. Okay, these are the kind of problems you get. You know, these are because it's coming out of a section in the book, which is inverse variation. Most of them are all going to be inverse. But still, they all work the same way, even when they're using a more complicated variation. They got to tell you, first of all, what kind of variation are we dealing with here? So that's usually the first thing in the problem. The variables x and y vary inversely, right? Second, you need to know what k is, so they've got to give you all the values of the variables for one point, so you can plug them in and solve for k. And then once you know it, they can ask you a question where you can answer the question. So this one, the variables x and y vary inversely. Y is 7 when x is 4. Write an equation that relates x and y, then find y when x equals -2. Right? It's always pretty much that order. Now, sometimes they don't ask you a question at the end. They may just say, find k, in which case you would be done at that point. But generally, they have all three parts. So, you know, when I first look at this here, I'd say, okay, they vary inversely, so I write down y equals k over x. Okay. Second, they told me one data point. Y is 7 when x is 4. So let me fill that in. 7 equals k over 4. So now the only thing I don't know is k, so I can solve for k. K equals 28. So now I can finish my variation. It's actually y equals 28 over x. Okay, last step. Answer the question. Find y when x equals -2. Y equals 28 divided by -2, which is -14. Now, depends on how you learn this in Algebra 1. A lot of times in Algebra 1, they teach you that for this particular kind of variation, you could actually set up a product. You could say, because of this variation, we're going to talk about it. If I solve this here, right, y equals kx for k, I would get k equals x times y, which means the product x times y is a constant, always. So you could set this up like xy equals xy. 4 times 7 equals -2 times y. And then solve that for y. Do you remember doing it like that by any chance? Okay. Where I was before, it was taught that way in the book, and most of the kids came into class thinking everything had to be solved that way, and it can't. And in the end, the math is all the same. Now, if this was a direct variation, then it's actually a proportion. You could say y over x equals y over x, and then cross multiply and solve. Maybe you remember that one. But those are great for those two, but it wouldn't help you when you get into the more complicated variations. That's why it's better to have this process, right? Write down the variation, find k, answer a question. So try this one. Oops, didn't go. What happened? Oh, internet, I think probably happened because I do this every once in a while. What happened to this? Let me do this. It'll be in there somewhere. And I do not know what's gone on with this. Is there any spurious? So it looks like it's closed it out. What, this? That's the recorder. That's not the Active Inspire software that I use for my, oh, here it is. There we go. Okay, now we can do this again. Try that. Down the variation, y equals k over x. Substitute values, -1 equals k over 8. So k equals -8. So y equals -8 over x. All right, answer the question. Find y when x equals 2. Y equals -8 over 2, which is -4. Right? Too easy. Now let's try not to mess this up again. So if you're given data and you want to check to see whether it's direct or inverse, then as I just showed you, for a direct variation, if you solve for a k, you get k equals y over x, which means even though x and y are changing, they're variables, their ratio, y divided by x, is always a constant. So if you're given a bunch of data, a bunch of x, y points, then divide all the y's by the x's, see if you always get the same thing. If you do, it's direct, right? If you solve this one for k, you get k equals x times y. So it's the product which is constant. So just multiply them together and see if you always get the same thing. If you do, that means it's inverse variation. All right, okay. So, for example, in this first set of data, I'm going to check first to see if it's direct. I usually just do it in order, right? So I want to check y divided by x. Okay, what's 2.4 divided by -5? You got a calculator right there. Negative what? 0.48. How about 4 divided by -3? Negative 1.3. So if I'm checking the quotients, clearly they're not constant because the first two were not even equal with each other. So we have to say not constant. So it's not direct variation. Okay. Okay, try the product. What is x times y? -5 times 2.4. -12. How about -3 times 4? 4 times -3. 8 times -1.5. -12. So every time we do the product, we get the same thing. It's constant. So we say that is constant. Therefore, inverse variation. And what is the value of k? K equals -12. Okay. Okay, then try the second set of data. Okay, first I'll start with direct, meaning check the quotient. Y over x. 8 divided by -4. 4 divided by -2. Negative 2 divided by 1. 6 divided by negative 3. So what can we say? So this is constant. So it's a direct variation. What is the value of k? Negative 2. So that brings up a point, which is, you know, if you're looking at this data and you're going to make a quotient, right? You may be just because you see the x values on top that right away you go negative 4 divided by 8, negative 2 divided by 4, right? You do actually the flip of it, which is going to be a constant, right? If this is a constant, then you do the flip. It's a constant, but that's not k, right? The k has to be y divided by x. So don't just automatically start dividing. Think of it. It's y divided by x is k. So direct, inverse, or neither? Anybody? It's a neither. Why? I mean, when you do the y over x, you get 3 and 3 and 3. And if you just start doing, well, obviously it's direct, you would miss that the last data point is actually not 3. It's 3.25. So not constant. So make sure you check to the last data point. So this is neither. Okay, so in this problem, it's a word problem. And it says the table compares the area A, capital A, in square millimeters of a computer chip with the number C of chips that can be obtained from a silicon wafer. Write a model that gives C as a function of A. Okay, they didn't tell you which one is it. So you have to check the data first and determine, do you think that this is inverse or is it direct? So try it out. Check all the y divided by x's and then check all the x times y's and see if there's one of them that's constant. What happened to the calculator? The calculator died on me before. There we go. So when you do the y divided by x, is it constant? No. How about when you do the x times y? You know, it's not exactly constant, but if you do all 4 of them, they're all just a little bit plus or minus from 26,000, aren't they? I mean, what was the smallest of them? 58 times 448. 25,984, right? That's 16. That's 16 off. Let's say what's 16 divided by 26,000? 6.15 times 10 to the negative 4th. So very, very small, right? 0.06%. And if you look at every one of those, although it's not exactly constant, it's so close, like as a percent, that in the problem, it's considered to be, you know, for real world application like this, we're going to consider that constant, right? And it looks like that the K is 26,000. So we have an inverse variation. So it says write the model. We're going to write a model that says it's not X and Y, it's actually A and C, right? And it says C is a function of A, which means that the C is like the Y and the capital A is like the X. So we should write it as C equals 26,000 divided by capital A. Now, predict the number of chips per wafer when the area of a chip is 81 square millimeters. What are we expected to do with that? The 81 represents what? C or A? It's A, right? So plug in 81 here. Boom. So C equals 26,000 divided by 81. About 321. Okay. So a joint variation is a Z, you need another variable because it's going to be a variable varies jointly with a product. So you're going to have at least two variables in the product, right? And then another variable that it's solved for. And it could be more than two variables, right? It could be Z equals K, X, Y, W, right? Then it would be a joint variation with X, Y, and W. Most of the time you just use two. Not much to copy on that side, huh? I hope. So now we can answer, do the same kind of problem, except now the variation could be varies jointly. And I think I had a mistake on, was it this one? No, it's one of the ones that comes after. I got to fix. Okay, so Z varies jointly with X and Y. Z equals K, X, Y. Z equals negative 75 when X is 3 and Y is negative 5. Negative 75 equals K times 3 times negative 5. So negative 75 equals negative 15 times K. So K equals 5. So here's our equation, right? Z equals 5XY. So we can answer the question, find Z when X equals 2 and Y equals 6. Okay, we ready? Priyashi? Okay. So try to do the same thing with that. Do I have this right? Yeah. So try that. So it's a joint variation, so I'm going to write down Z equals K, X, Y. Substitute. Z is 56 when X equals negative 6 and Y is negative 4. So 56 equals positive 24K. So K equals 56 over 24, which is 7/3. And then I can fill in my formula. Z equals 7/3 XY. And then answer the question. what is the value of z when x equals -2 and y is 5? And that would be -70 over 3. If you turn it into a decimal, -23.3. Remember, every time you do something like that and you turn it into a decimal, it's not quite as accurate anymore. As soon as you truncate that decimal, it's not quite as accurate. If it's like a technology enhanced item on the SOL where you've got to like fill in the blank, putting 23.3 and not the fraction is going to cost you getting it right. So combinations, if you notice the first one, y equals kx squared, you would say y varies directly as x squared, right? What if it was y equals kx to the third? Y varies directly as x to the third, right? So this could go on forever, right? So there's not like a finite set of combinations that you could encounter. It's infinite. So this is not like an exhaustive list of here's all the different combinations of variations that you can come up with, because like I say, you can come up with infinitely many of them. But like the first one, y varies directly as x squared. The second one, z varies directly with y and inversely with x, right? It's inverse because it's in the denominator, right? What is the next one? That's just a joint variation, okay? But what about the next one? Would that be joint also? When you put the x, y in the denominator? Could you say inversely, jointly, combine it? No. You would say z varies inversely with the product. You don't use joint just because it's a product, because it's a denominator, right? So this is joint, this is inversely with the product. And then here's one, z varies directly with x to the third and inversely with y squared. Let's see if you can conjure up some of these. Oh, and this is the one, this should say y, just a second. I'm just going to write it here. I should have come up with better examples of that. How'd you write the first one? Y equals, say again? No. KW over X. But thanks for saying that, because that's what I was about to say. Is one of the main mistakes that I see is that when you write the variation, you don't put K, right? And so now you're nowhere. You're plugging in numbers, but there's no K to solve for. So you should just think as soon as you see the varies word, write down K. It's always got a K. How about the next one? It's jointly with Q and R, so it's KQR, and inversely with S divided by S. So make sure you write down the K. It's good. It's all good, Lauren. That's it. So I want to read through these for a sec. Translate. Y varies jointly as X and Z as that varies. So again, I just copied and pasted from the SOLs. You could see how they used the directly proportional and inversely proportional. They didn't say varies, but we get the point, right? Determine the value of the constant of proportionality and set up and solve real world problems. Okay. So if things go like I expect, I would expect that we'll go over this homework on Wednesday, and then on Friday we'll take a quiz just on this stuff, just that. So homework, which you just work on now, you could listen to music. Please just work on it, get it done. It's a lot of problems.